All right, folks, sorry that I'm not in the room today, but Ms. Swen is going to be covering. And you've already taken the quiz and shown me your homework, so we should be all set on that. But now that we are done with the quiz, you can get started with learning something brand new called U-Substitution. And in order to do that, you've already taken a look at this do now, which you have right here. And it's kind of a tricky problem because we have this cosine of 4x. And it's not just the cosine of x. Of course, the integral of cosine of x is sine of x plus c, and we know that. But the cosine of x, of 4x, is different than the cosine of x. We have this issue with the 4. What happens when there's a function inside a function? It's kind of like what happens when we deal with the chain rule when we're taking derivatives. And that's what we're going to get a hand from. So you may have said that the cosine of 4x is sine of 4x plus c. Let's check to see if that's right. Of course, when we take the integral of something, if we take the derivative back, we should get to the original function again. So let's take the derivative of sine of 4x. Well, the derivative of sine of 4x, we have to use the chain rule, which means we get the cosine of 4x, but we also have to multiply by the derivative of what's inside. So we get that extra 4 that pops out over here on the side. So that's no good. We can't have the derivative not equal the original function, right? The integral of cosine of 4x cannot be sine of 4x because the derivative of sine of 4x is not cosine of 4x. It's 4 cosine of 4x. It's a little bit tricky. And the big idea here is if we have a function inside another function, like 4x inside of cosine, instead of just plain x. In other words, when we have a situation where we don't have just plain old x inside our functions, then we have to use something called U-substitution. And it turns out, maybe some of you guys were slick enough to figure this out, that the answer is actually 1/4 sine of 4x plus c. And if you take the derivative of that, you get cosine of 4x, and then that 4 that gets popped out from the chain rule cancels out with that 1/4, and we're left with just cosine of 4x. Anyway, that's something you can play with on your own. So what we are going to do is formalize something called U-substitution. So here's U-substitution, and it's a technique for dealing with those types of integrals that you just saw. And I'm going to just read this. In order to do the chain rule in reverse, which is what U-substitution is, we need to substitute in a u for the inside function and change the problem to be in terms of u. Now, I've heard that you guys use this u stuff when you were doing the chain rule back with derivatives. And see, that might be overkill, right? With the chain rule, eventually you got to the point where you could do it without writing the stuff in terms of u and da-da-da-da-da. Okay, that was the chain rule. This is U-substitution. Okay, there's a reason why it's called U-substitution. You must go through the steps of using the u. At first, it might seem easy, but it's going to get a lot more complicated. And we're going to follow my steps exactly to make sure that we're going through the problem properly. So here are my steps, and that's what I want you to write down. So you might want to title in your notes U-substitution, and then you might want to pause on this slide because I'm just going to read this once, but you definitely want to write this in your notes. The first step is to identify the inside function. That's a lot like the chain rule. You want to figure out, hey, what's on the inside here? Okay? And then on the side of your page, you want to set that inside function equal to u. After that, we're going to take that u and we're going to take its derivative. We're going to find what's called du dx, basically the derivative of u. And then we're just going to rearrange that side. This is the trickiest part. We're going to rearrange that so that we have dx by itself. We're going to solve for dx. Afterwards, we're going to plug everything back in and integrate. So let's see how this goes. Pause here if you want to write this down, and you do, because we're about to do some examples. So here we go. Let's do the first one. So in this case, instead of just having plain old x cubed, we have the integral of 2x plus 1 cubed, all in parentheses. And so this is not just a plain old x, and that means that we probably need to use U-substitution. So the first step, if we realize we need to use U-substitution, is to identify the inside function. In here, you can see instead of just x cubed, we have 2x plus 1 cubed. So I'm going to go ahead and say that the inside function is 2x plus 1. Now, this is important. If you screw up and choose the wrong inside function, that's okay. You'll go through the problem, there'll be a mistake, you'll get to a point where you can't move on, and you'll have to stop, go back to the beginning and say, oh, I chose the wrong inside function. Or you just try something else. Maybe you can't figure out what it is, but you should try multiple tries before you give up. Okay? Like if you're on a test and the first time it doesn't work, you're not going to freak out and just give up. Okay, you try a different inside function. And here I'm saying the inside function is 2x plus 1 because that's inside the function, the cubic function here, something cubed. Okay, next step. On the side of your page, set the inside function equal to u. That one's easy. You just write u equals the inside function. So in this case, we have u equals 2x plus 1. Okay? And so again, we've selected the inside function, it's 2x plus 1, and we set it equal to u on the side. Next step. Find du dx, which means take the derivative of this, okay? If you have u equals something, then we say du dx equals the derivative of that side, okay? What is the derivative of 2x plus 1? Well, du dx is equal to 2, of course, because the derivative of 2x is 2, and the derivative of 1 is 0. Now here's the trickiest part, this might be kind of confusing, okay? The next step is to solve for dx. So here I have my friend du dx, okay? And it's kind of like du over dx. So you can really move these things around. If you slide dx over to this side by multiplying both sides by dx, and bring the 2 down to the bottom by dividing by 2, you end up with this. And if you want to just take the shortcut is to just swap the dx and whatever's on the other side of the equal sign. You end up with the 2 down here and the dx on that side. Okay, so we set something equal to u, the inside function, we took its derivative, and then we swapped the 2, or the answer on the right side, with the dx, okay, and we're left right here. So now we have dx, okay, and we have u. All right, so what are we going to do next? Next thing to do is to plug back in for dx and for the inside function. So now that we're done with our stuff on the side, we come over to our original integral, and we replace a whole bunch of stuff. You want to take the inside function and replace it with u, right? 2x plus 1 is now u. Okay, and we want to take the dx and replace it with whatever it's equal to. In this case, it's du over 2. So this is what the next line would look like. You take the 2x plus 1 and replace it with u. And you take the dx and replace it with whatever it's equal to, like this side over here. Okay, this is starting to look a little bit easier, right? The next step that I could do is to integrate, and then we're going to be done. So this over 2 on the right side here, I'm going to move that out to the outside just to make my life easier, right? That's the same as a 1/2 on the outside. Recall the rule about integrals where we can pull stuff out to the front. And then all we have to do is take the integral of u cubed du, which is not that hard. It's just like the integral of x cubed dx. We take the 3, we raise it by 1, we get u to the 4th, and then we bring that 4 down to the bottom, we get that 1/4 u to the 4th. And of course, don't forget our plus c. Our 1/2 is still chilling on the outside, so we bring that back in. That gives us 1/8 u to the 4th, right? Remember the 1/2, we don't have to put that in front of the c, because c can be anything. So c and 1/2 c, those are just the same thing. And then the very last step, u is made up, right? You made up u. It wasn't given to you in the problem, so we just put this back in terms of x. So instead of using a u here, we replace it again with, well, u is still equal to 2x plus 1, so we put that 2x plus 1 back in there and get our answer. 1/8 times 2x plus 1 to the 4th plus c. So that's a long process, but you have to go through all the steps. Start by finding the inside function, 2x plus 1, set it equal to u on the side, differentiate it, find its derivative, rearrange so you get